welcome to our session. Hope you enjoyed your lunch. So let me start with a question. Who of you is managing infrastructure or has to do something with infrastructure? Most of you. Really good. Would be confused if SREs.
What is the rest doing?
They use it. They use it. Okay. All right. So, do you configure infrastructure? Yes. Well, I have to tell you something. Please stop doing that. Please stop configuring your infrastructure and start coding it. Why? Well, if you want to become an infrastructure wizard, then we want to help you to be that. You're in the right session today to learn how to become an infrastructure wizard. And my name is Martin Sakowski. I'm a senior solutions architect at AWS, and I've built a lot of infrastructure in the last 16 years of my work. And currently I'm working with large retail enterprises in Germany and also deal with a lot of infrastructure there.
All right, hey everyone. I'm Julian, also solutions architect with Amazon Web Services. I work with enterprises in Germany in the media and entertainment industry. So also quite a lot of bigger projects and topics. But one thing that is very close to my heart is serverless technologies, but also improving the lives of developers and developer experience. So that's why this is also one of the topics quite close to my heart.
So we both have built tons of infrastructure in our past. So why do we need to talk about this topic, building or coding infrastructure? Well, in order to understand this, I think we have to go back to the dark ages and see how that all started with our infrastructure. And there's something, maybe some of you might remember that time, where we had those manual deployments. And that means we were clicking through the console. We had some wikis, we had playbooks. And well, the thing was with like all those descriptions, sometimes something was missing. And then we had to find the person who knows everything and could help us while deploying that. And that was not so easy. Well, we found out that there's a better way of doing that. And we created scripts, bash scripts. We used CLIs for that. We called APIs a lot. And that, to be honest, worked really, really well. Until it didn't. Because those scripts got very, very complex. And if you know Bash, you know it's not designed for complex deployments. So it was often hard to maintain those scripts. And we always said, like, it works, so better don't touch it. Otherwise, it will be broken afterwards. So wasn't the best approach, maybe. And then something else came up. And I think like all the SREs liked it a lot. That was like the declarative approach. We get services that can do like infrastructure provisioning, for instance, CloudFormation, but also Terraform. And the cool thing was like those services helped us because they reduced the complexity a lot. You don't have to deal with state management anymore, rollbacks, drift detection, like all those difficult things that were like really hard in shell scripts that was solved by the services. So the developers had only to describe their infrastructure and hand it over to the provisioning service, and that one deployed everything. And from that, the term infrastructure as code was born and widely adopted, obviously. So we can say infrastructure as code, perfect, we are coding our infrastructure, do we? Well, if we look into this in detail, we see we are writing JSON files or YAML files or HCL files. Is it easy to define a complex infrastructure with JSON, YAML, and HCL? Let's do a check. I give you a task. Let's assume we're tasked to build this really simple, highly available web application with CloudFormation. You can say, oh, that sounds easy. I get like all the traffic from the internet that goes to the application load balancer, and then I have to process that with the EC2 instances, attach an autoscaling group so it's highly available and scalable. Sounds easy. Have you ever configured something like this in CloudFormation, for instance? I think most of you did. I did as well. Guess what? I counted the lines. It's over 300 lines of YAML code. I wouldn't say that is easy to build something super simple. So why do we need a few hundred lines of YAML code to solve that? If we unpack that CloudFormation template, we will see that it's made of many individual resources. So we not only have the load balancer and the EC2 autoscaling group, well, we also need a launch template so we can define the infrastructure or the configuration of the instances. We have to deal with all that networking stuff. We need something like a VPC. We need subnets, route tables, IP addresses. What else do we need? Security groups maybe, NAT gateway, internet gateway. So many resources in order to set up this one. And imagine this is not getting easier if you have like a really complex infrastructure. If you use like Kubernetes clusters, for instance, and so on. So there's a lot of things, small things you have to wire together in order to make this infrastructure work. And those small things and wiring all of them together requires so many YAML or lines of YAML code. And the thing is, it's not real code. So it's hard to write that code, it's hard to maintain that code, and it's hard to organize that code. Well, how can we make that easier? Well, we could build generators. Generators are great because you can code something and it will generate those YAML files. And that's a good idea and definitely like the right approach. But you still have to configure and wire like all those small components inside of it. And in order to solve that, we would need higher level of abstraction in order to simplify the entire process. And we want to talk about this layer and tools like Pulumi or the AWS Cloud Development Kit, or we call it CDK in short. And I would say this is different to infrastructure as code, and I call this layer infrastructure as actual code. So we don't have YAML files in JSON anymore, but real code. And this code has several layers of abstraction in order to reduce the complexity. And today we want to show you why we believe this is a great idea, and also how you can use the CDK in order to become that infrastructure wizard. Julian.
All right. So let's take a look at the overview, what CDK actually is. So CDK stands for Cloud Development Kit. So it's an open source framework to provision and describe your infrastructure. And the few main benefits that you get with CDK is, first of all, you can use a familiar programming language. Right, so we'll see in a minute what this means. But basically, if you have a programming language, you can use the functions, methods, and tools that you already have. Right, so from tooling side, you can use your favorite IDE, the plugins, and all these things that come in general if you use a programming language like that. Another thing that you get, and we just talked about it in the lunch break, is what Martin also mentioned. You have a huge file of YAML code, right? And if you are a developer and you worked with an object-oriented language, what do? You structure your code, usually. Some don't, right? That doesn't work most of the time. But if you structure it properly, you get a much better overview and usability of your code. And you can apply the same principles for your infrastructure in this case. The programming languages that are supported is TypeScript, JavaScript, Python, Java, C#, and Go, which is in developer preview. So flavor for everyone, or most of you, I would say. And this also what brings you the tooling and the benefits that you get from these languages. For CDK itself, some of the main components that you're going to interact with or that you need to know about is, first of all, the core framework. So the core framework basically groups your application into an app. So this is the logical grouping that you get with CDK. Below that, you have stacks. So an app consists of one or more stacks. And if you ever worked with AWS CloudFormation, you heard the term stack. And this is exactly the same thing, right? So the stack is a unit of deployment. Here also similar to what you have with CloudFormation. And in a stack, also in CloudFormation, you have some resources, right? So if you have AWS services that are configured, your resources, S3 buckets, VPCs, Lambda functions, so those resources. And the additional layer that you get here with CDK, and that we're going to talk about more in detail later, are constructs. So this is basically a logical grouping that gets introduced with CDK that allows you to group your resources in one additional layer. The other part is the CDK construct library, and this is quite important to know about. So this is basically developed by AWS, predefined constructs, predefined defaults that you can use, so a library that you import to actually build your application. And the last one, that's what you see, that's what you interact with, is the CDK CLI. So the tool to use to actually build your application from scratch up. How do you use the CDK CLI? So you start with a CDK init. It generates you the skeleton, your basic building blocks, your files to get started. And there you write your source code. You write your constructs, you define your resources, TypeScript, Python, whatever you decided in the beginning. And then, since in this case we're using TypeScript, you can run an npm run build to run your tool chain, right? Do you want to run any tests, any checks, any building process that you want to do? Can use that similar to what you would use if you would use TypeScript, Python usually. After that, you synthesize your stack. So this is what the CLI actually does. It takes your Python code, your TypeScript code, and translates that to what we call cloud assembly. It basically takes your code, translates that to a CloudFormation template, and also includes any assets that you refer to, maybe scripts or something that you need to run your application. And then the actual deployment happens. And as you can see, CDK doesn't actually provision the resources in the cloud. So what it does, it generates CloudFormation templates, deploys them to CloudFormation, but the actual provisioning and state management, this is something that is handled through CloudFormation. So here you can see CDK is actually happening on the client side. So this is something that is locally. So there's no CDK cloud service involved, but this is all happening through CloudFormation in the end. Additional thing that you get with CDK is basically a paradigm shift, especially if you work with multiple environments. So usually if you know CloudFormation, if you work with it, if you have multiple environments, you have usually one big template with a lot of parameters, intrinsic functions that enable you to differentiate between the different environments within your template. Now that we have an object-oriented language with CDK, this can shift more to the left. So in your object-oriented language, in your CDK code, you can use classes, methods, interfaces, whatever you need to structure your code, to define your environment, to configure that properly. This is what you can define in your language. And this actually generates two templates in this example. And these two then can get deployed into the different environments. So now, I talked quite a bit about constructs already. And now let's see how they work in detail.
Yeah, as Julian mentioned, constructs are these abstractions of cloud resources. And let's try to understand better how this exactly works. So this AWS CDK includes this construct library, so a set of all those constructs. And those constructs are reusable cloud components. So you can say these are the basic building blocks of your infrastructure, and those building blocks represent AWS resources. And they can represent a single resource, a group of resources. They can also represent an interaction of different AWS resources or even different AWS services and how they work together. So in order to better understand how that exactly works, I think it's good to classify them, because we have different types of constructs. And we have 3 different levels for this. The first one is level 1 construct. I always call them low-level constructs because they only represent a single resource, and they're on the same level as CloudFormation. And then we have level 2 constructs, a higher level of abstraction, of course. They also represent AWS resources. They even represent a composition of multiple AWS resources. But still, all the resources have to belong to the same AWS service. And then there are level 3 constructs. And level 3 constructs are even higher level of abstraction. I also call them pattern. So you can say these are highly opinionated abstractions for a certain use case. And they typically represent the abstraction of multiple services and many resources, compared to, remember, level 2, which is only multiple resources within one service. So level 3 can be across the service boundaries. So let's look a bit into the details of that. I'm going to show you some code, because that always helps. So we start with level 1 constructs. And as I mentioned, it's a direct representation of the CloudFormation resources. So that means that you get access to every single parameter of the CloudFormation resource. That gives you, on the one hand, the full control about all the parameters. But, and that's the disadvantage, it also requires a lot of knowledge about like all the components or all the parameters, because you have to configure all of them. So you have to understand what you have to configure. I give you a short example here. In this example, we define an S3 bucket. We call this bucket my-bucket. And from this, as Julian explained, the CDK generates the following CloudFormation code. And you can see this is a direct representation. So everything I have configured on the CDK level 1 construct, you will find in the CloudFormation. So one-on-one mapping of the properties. How will that change with level 2? And by the way, level 2 are the constructs you should use, you should start with. Level 1 is only a fallback if you really want to do that, because you can import level 1 CloudFormation to level 1, and then you have that representation because it's a one-on-one mapping. But you should always start with level 2 constructs. And I said level 2 constructs, they can create a more complex structure, multiple resources, still belong to the same service, but they have an easier interface with a higher level of abstraction of that resource. And remember, the functionality is always the same as with level 1 constructs. You don't get additional functionality, but we often use same default values, so that saves you like a lot of this boilerplate code that you always have to write, but in the end you don't really care about those values a lot. So I want to give you an example, and you can see it's way shorter. It's like one line of code, and I define a VPC, virtual private cloud, so that's a network construct, and I call it my VPC. And from this one, I create way more, and I haven't shown the code because it would be too much code for that slide. But the CDK creates a VPC across 2 availability zones. You get 4 subnets. You get over 65,000 IP addresses. They even are distributed across the 4 subnets. You also get an internet gateway, route tables, and so on and so on. So everything you need for fully functional VPC, and you get all of this with just one line of code. That's the important part. And so it's quick and easy. A minimal configuration effort. But of course, if you want to change something, for instance, if you want to span this across 3 availability zones, if you want to have more subnets or less subnets, whatever, you can change all those values if you want, but you don't have to because you have same default values. So you still have the full control. And that is nice, but I want to show you something that I really like. I think that's the most important part of this talk. On level 2 constructs, you often get additional functionality. And I show you an example here. If you want to assign permissions. So let's assume we want to give permissions for our application to access another resource. So maybe you want to give read permissions or write permissions or so. And with the CDK, it's usually just a single line of code, and the resource gets that access to the desired resource. So here's that example. So we have a Lambda function in that example, and that Lambda function should read a file from an S3 bucket, and then based on the information on that file, it will create an entry in a Dynamo table. So pretty simple application. So in CloudFormation, what would we do? You know, we would usually have to create a policy with 2 different statements in there. One statement would be for the S3 read permissions, and one for the Dynamo write permissions. And of course, in order to apply best practices here, which I would highly recommend, you have to restrict the access. And then the Lambda function may not read like all the S3 buckets, but only that particular S3 bucket. And the same for the DynamoDB, not all DynamoDBs, but only that particular DynamoDB, and maybe like with reduced permission set, and so on and so on. With CDK, I would say that's way easier, because look at this. If you see like the lines of code that are in orange, there are two lines that are super important. We simply call grant read and grant write data. You can see that here, input bucket, grant read for my Lambda function, and the same for the grant write data. And then the Lambda function receives the read and write permissions, and they are automatically generated using best practices, so you don't have to do anything, just create that. And another example also highlighted there, this Python, you don't have to remember, like, I want to use Python 3.9, like, what is the correct string to do that? You get enums. You can just select from the enum the right version you want to do, so you don't have to remember that. So from complex becomes super, super simple if you want to do that. And did you notice something? The higher we went with the abstractions, we started to write clean code. So code that is understandable, code that I would say basically talks to us. And I think if you do that, it makes your infrastructure more understandable for everyone. Not only for the people defining the infrastructure, but also for other people who want to understand what kind of infrastructure we have. Well, how can you even simplify that? We have level 3 constructs. Level 3 constructs are even higher abstractions across service boundaries. And I got another example, not 1 line of code, but 4 lines of code, basically. And with these 4 lines of code, we create a VPC, a subnet, internet gateway, NAT gateway, route table, and so on. We also get an application load balancer, security groups, task definition, listeners, target groups. We also get an ECS cluster with Fargate service, IAM roles, policies, log groups. So you basically get an entire stack to run containers. Perfectly configured with just 4 lines of code. I think that shows how powerful level 3 construct is. And remember, the cool thing is you can write your own constructs. So you can write your own level 3 abstractions and think of like problems you usually solve in your company, and every team has to solve that. You can just put them in code, and everyone can reuse that. Or you can use constructs from AWS or from the wider community, or build your own.
All right. So now that you know the basics of CDK, let's go a bit deeper and see how you can actually deploy that and use that in your pipelines. So for that, let's go back again a bit to the dark ages, quotation marks. So how was it usually done, right? You had an infrastructure team, you had an application development team, you had a development or configuration team, DevOps team, and usually all of these 3 teams had their own tooling, their own code, their own configure or their own management tools to run your stack, right? Some in version control, right? Usually developers have that or should have that, but also infrastructure and in configuration management more and more towards that. So, Andy, as you know, right, SRE and DevOps teams, they try to make that easier, try to bring it together. But in the end, if you have a lot of different tools, it's still quite complicated. What CDK does and what it allows you to do is to bring all of these together into one single place, right? So as you have seen, you can bring together your application code. So for example, for your Lambda function, your scripts for your ECS, your container images, but also your configuration and your infrastructure definition, all in one place so that you can have a unified team and unified configuration and unified tooling for that. So what you often heard and what we use also at Amazon and AWS is two pizza-sized teams, and those teams have a mixed team that work on the same tooling, work in one team together on the resources. So this is something that at least allows you to do. You don't have to do it, but you can do it with CDK. One of the best practices and something that we actually get asked by customers quite a lot when talking about CDK or deployment tactics and techniques is how do I use that with multiple accounts. So let's take an example. Martin and I, we are the developer in a company. We want to do something. We want to develop something with CDK. And each of our developers has their own AWS account, right? So our Playground account, we can play around, test certain things, do our own deployment there. Once we are happy, we put that in a version control. This triggers a pipeline. The pipeline is in a shared services account. And this account or this pipeline then actually deploys that to our free production or to a free shared accounts, right? So a dev, a staging, and a prod account. If we now take a look at the GitFlow example of how such development would work with GitFlow, we start with 2 branches, right? We just had our version 1.0 release. Yay, everybody's happy, but work's not done, right? We need to work on the new features. We want to build a waiting queue features. Right now, we have our free accounts again, all on the same version, all in the same state. So we start creating our new feature branch, start implementing the first commit, the first infrastructure changes, application changes, push that to our feature branch, which triggers a change in our dev account, right? So we create a new environment in our dev account with our feature. We do a few more changes. Now we're finally happy, right? Waiting queue feature is done. We merge that back to our main branch and do a deployment to our dev account, right? So now dev, the 2 environments are in the same state again. we have to do a release at some point, obviously. So we create a staging account, QA takes a look, testing takes a look. Once everything is happy and done, we do a few more commits to fix some bugs that we forgot about, and we push that to our staging account, right? Once we do the release, we merge to our main account and do the deployment to our prod account and merge back to development branch to get the changes also to our development environment again. So we're all in the same state. So this is all nice, looks quite easy, right? Standard workflow. And I think the main benefit that you get is what happens if there's an issue in production. So now that we have everything in one place, what we can actually do is go from a version 1.1 and roll back to version 1.0. Right? This obviously also depends quite a bit on the application and it has to support it. But overall, you have everything that you need to know about the application in one place, ideally, and can roll it back to version 1.0. How do you integrate these environments in CDK? So I've seen these questions from customers also quite a lot. This is not CloudFormation. So you're not restricted to what CloudFormation, for example, gives you. You have TypeScript, you have Python, you have a programming language, and please use that, leverage that. You can put in your own properties in your constructor and use that in your code. Use it to define your environments. What you can also do, here basically the example is to actually pull that from the environment variables from your pipeline, put it into the constructor. And the last part, and this is something that you get from CDK out of the box, if you want to go to a different environment, to a different account, you can just define that, right? Give it to the stack, then account and the region which you want to deploy. So CDK automatically handles that for you, can define it in your pipeline, which account it should actually deploy your stacks. All right, so with that, Martin, let's summarize it.
Yeah, so looking back at your experience with like configuring infrastructures, did you get JSON or YAML phobia? I got that after a couple of years doing that. And if you want to become that infrastructure wizard, well, then stop configuring your infrastructure and start coding it. It's the best approach of doing that. Many good reasons to do that. So you get infrastructure as actual code, not only infrastructure as code, which is not real code. So you don't have that YAML or JSON. You get real code. You get familiar programming languages, so nothing new that you have to learn. And of course, all those programming languages, they come with great IDE and tooling support. Even think about like coding assistance also will help you a lot with that. And it gives you powerful abstractions. So we showed you a few examples. Imagine 30 lines of code instead of writing 300 lines. I think that's a huge benefit if you look at this. And the quality of the code is way better. You get clean code. Code that is understandable, code that actually talks to you. And one more thing, as Julian mentioned, you can finally use GitOps in a unified approach for your entire application or your entire stack. So, well, should you go home and start rewriting your entire infrastructure? Maybe. But if you're happy with your current configuration and tools like CloudFormation and Terraform, that's fine. They also do a good job, and we don't want to tell you you have to replace that. But if you don't like that, the way how those tools work and the process behind it, we wanted to show you this easier path, the infrastructure's actual code paths. And I would suggest, before rewriting an entire project, just start the new project or maybe a POC with that approach and get familiar with that. Yeah. And the cool thing is you're not the only one working with CDK. Actually, CDK is a huge community. As mentioned in the beginning, we said that CDK is an open source project, so we have a public roadmap on GitHub. You can see what features the community is requesting. You can write your own feature requests. You can upvote features if you want. And of course, you can also work on the CDK yourself. More than half of the commits are actually coming from the community. But before working on the CDK itself, I would recommend working on constructs. You can write your own constructs. Level 2 or even level 3 constructs, and then you can share them with others. You can share them with the community. We have the construct hub that is basically, I would say, GitHub for constructs. We already have over 1,600 construct libraries in that construct hub, so you can check them out and maybe create your own version of it. And there are like since that concept of CDK is really successful, there are new projects based on the CDK. For instance, we got CDK for Terraform. We explained like CDK is using CloudFormation for the provisioning. CDK for Terraform, there you don't generate CloudFormation templates, but you create a Terraform configuration, which is then provisioned by Terraform. So replacing the CloudFormation part. Or you get CDK for Kubernetes, where you get the YAML configuration for Kubernetes based on the concepts of CDK. So I would say CDK is a very modern approach of building infrastructures on all different levels. And that's why we want to encourage you to start your next project using the CDK. If you want to learn about this approach, we have some workshops online. Just check them out and test it a bit. And if you want to learn more, contact me or Julian. We're here after the talk as well. So what we want to tell you today is stop configuring your infrastructure and start coding it, because CDK is the way to code your infrastructure. Thanks a lot for being here in our session today. And since we value your feedback, please take a minute and provide us some feedback if you like the talk. If you like CDK, just scan the QR code and give us some feedback. And do we have time for questions? No, I don't think so. We have? Okay, perfect. Any questions?
Thanks for the talk. It's good to see it in practice. My question is, during the talk, you mentioned the fact that we're using bash scripts for scripting infrastructure and the problems with that, and then demo the same with TypeScript. And I guess my question is basically, how do you make sure that the script that you're using to generate the infrastructure does not get too complex at the end of the day? Because with programming, you have several constructs, so much power to do. So how do you manage that?
Yeah, really good. Yes, still you have to be a good developer. So that doesn't really help. If you don't know how to write code, you shouldn't do that. But yeah, compared to the bash approach, there's something different, because the actual provisioning, all this handling of the state and so on, this is done by CloudFormation. So you get fully abstracted from that. You just describe that. But if you write CloudFormation templates, it's difficult to do something if you want to have, I don't know, an array with 10 different things and you want to deploy that 10 times. Well, it was really hard to write this. And with programming languages, it's way more easier because you can use for loops and so on. You can use all those tools. So it simplifies the code a lot. Even without using those abstractions, you have different ways of writing that, because in the end, you're not using a declarative approach to write the code, but behind that, it's still using the declarative approach to provision everything. And that's a good way of doing that. If you provision with a declarative approach, but defining it, it's hard to do that in a declarative approach.
I think summarizing it, with great power comes great responsibility. So with CDK, you can write great or clean code, but you have also the chance to write quite horrible code. So, but at least you have the possibility. Any more questions?
Hi, thanks for that great talk. In your opinion, of all the languages that are supported by CDK, is there a difference in how mature a particular language ecosystem has become with respect to support for CDK? My question is particularly to understand which language ecosystem to start with if I happen to be on a team which does not use any of these languages. Which language would be the best choice?
Yeah, so obviously, as you mentioned, right, if you have a language of those and your team uses it, you are right familiar with that, have the tooling, then use this language. If you look at CDK, at how it is built, it is built from TypeScript, right? So the in quotation marks native language of CDK is TypeScript, and the other languages, so Python and so on, they are derived. So there's a GSII compiler that basically derives the Python and the C# version of that. So I would say in the end, there's no lack of features between the programming languages, right? So they are equal and they are automatically generated from that. if you want to work closest to the native version, then it would be TypeScript. But in the end, that's in overall, it's more of a preference, right? So what do you want to go with?
Thank you.
All right. Anyone else? Oh, there. Yeah. Didn't see it.
This is more of a personal question, actually. Thanks for this. I think I joined a bit late. But if you're like in a new projects right now and you need to start doing stuff like AWS accounts management or any of those like lovely things, what would you be using? And be honest.
So, you want to, or should I? No.
So my default is always CDK. So I would recommend to do everything in code because it makes it easier. And even if you think like for the first time, it's easier to click through the console. In the long run, it doesn't help you. So always try to use in codified way. And my default is CDK. Of course, you have to get used to it a bit. So that's why I would recommend like starting with the next like smaller project to get familiar with that. But yeah, it's once you're familiar with that, it's the easiest way of doing things.
Interesting. The other question. So obviously Terraform, many people face these same issues with like module changes and the provider just changed all of a sudden and you didn't pin your version and then you're faced with a bunch of issues. How does CDK sort of like manage like API changes and stuff like that?
Yeah, like this is like normal dependency management. And you can pin them all in your like you have a construct library that's just like an external dependency, and you have a version and you can pin them and then you can make sure like you don't have like any changes that are automatically introduced.
Nice, amazing. Do you guys have any repo with examples of CDK?
Yeah, we can.
Oh, yeah. Oh, thank you.
Actually, there are some of the resources. If you just Google for that, so cdkworkshop.com is, I would say, the go-to resource to get started, right? There's some labs and some things to get started and try it out. But obviously, you can also just find it on GitHub and take a look there. All right. Oh, right in the back. You're already waiting to get started, right?
I'll be quick. I joined a bit late, so sorry if it has been discussed already. But it seems that initially from code, people have start preferring more declarative languages like JSON or YAML over the time. And are we experiencing now back preference to normal code as opposed to declarative YAML?
Yeah, so at least from our experience and what we see from our customers, obviously we are in somewhat, right, we are now working a lot with CDK, so we see that a lot, but also talking to our customers that we work with, we see that as heavily asked, these kind of things, right? Because this is more closer to the developers and they are more familiar with that. If you go to the developer, and you probably all know this, and you say, hey, here's a big YAML file or here's a big JSON file, take care of that, they'll probably say to you, no thanks, right? Please take that care on your own. So, and as we mentioned, right, there are multiple ways to approach that, and it's in the end, it's a preference of the team, right? So there's both things work, and in the end, you have to decide what works better with your circumstances, and especially with the teams, with your tooling and your experience. So to make use of that, don't force a change of say, now we're doing everything in Python, but no one of your team knows Python. This will probably not give you any benefit in the end.
Yeah, makes sense. Thanks.
Which one you'll prefer, CDK or SDK? Because whatever CDK can do, even SDK can do. And SDK can do, it's already integrated before CDK was there.
Yeah, so if you're talking about the AWS SDK, obviously you can trigger all the APIs to create resources and do all these things, but it's a different side of the tooling chain, right? So with CDK, you get CloudFormation in the end, and you get the state manager and all these things. You could, in theory, obviously write something with SDK, but if you want to really define your infrastructure and do a proper state management and infrastructure management, then use CDK, CloudFormation, or Terraform, so a tool that is made for managing infrastructure. Else you would kind of, with SDK, you can do infrastructure changes, but if you work around your state management, then it can be can bite you at some point. So if you don't want to reinvent the wheel here, yeah.
Yeah, basically, if you look at this chart, what we had in the beginning, you have CDK, it translated that to CloudFormation, And CloudFormation, of course, in the end, it's all one API. CloudFormation is driving those APIs, and the SDK is driving these APIs directly, but you don't have like all these infrastructure deployment mechanism, and they are super important, especially if you have complex infrastructures and rollbacks, drift detections, all that stuff. You would miss all of that if you only use the SDK. We sometimes see that the basic infrastructure is built with CDK, and then you have something to interact during runtime, and that this happens with SDK. So that's like they can work together perfectly. But I would always recommend like the real infrastructure, like this layer, you should always provision through like a real provisioning service like CloudFormation, and CDK is just an abstraction of that.